Hi students, hello everyone and welcome to our YouTube channel. So our today's class is to about calculate the n factor or valency factor, right? Like you know very well that in calculation of normality, molarity or Van 't Hoff factor, there is the requirement for calculation of n factor of that compound. And student face very difficulty that what is the n factor for like NaCl, HNO3, H2SO4. So in today's class, we will discuss about how to calculate n factor with a very super easy trick. You can calculate this within second after this video. So hope this video will be helpful for you. Let's start without wasting any time. So firstly, in case of acids, the dissociation of the acid is must. Like in case of acid, we firstly dissociate the acid and then our n factor is equal to total number of H ions. For example, in case of HCl, we dissociate HCl firstly, then we will get H positive and Cl negative ion. So what will be the n factor? N factor is total number of H positive ions. So the total number of H positive ion here is 1. So n factor here is equals to 1. Now in case of HNO3, now dissociate this as well, we get H positive and NO3 negative. Then how many H positive ions are there? 1. So n factor is equals to 1. Now in case of H2SO4, we will dissociate, then we get 2 H positive and 1 SO4, 2 negative ion. So how many H positive ions are there? 2. So what will be the n factor for this H2SO4? N factor is equals to 2. Now in case of CH3COOH, named as acetic acid, it is a very weak acid. It is very weak acid, but its dissociation is CH3COO negative plus H positive. Here also H positive is equals to 1. So n factor for acetic acid is also 1. But in case of these compounds like SO2, CO2, SO3, there is no H plus ions is shown firstly. So we add water here. Firstly we make them acid and then dissociate, like SO2 with H2O produce H2SO3, CO2 with water produce H2CO3 and SO3 with water produce H2SO4. Like this is same, n factor is equals to 2. Here also 2H, here also 2H, then n factor for these compounds is 2. So it's very easy trick that firstly dissociate the acid and then the H ion is equals to the n factor. But in case of the compounds like phosphorus compounds, in that case your n factor is equals to total number of oxygen minus 1. Only calculate the total number of oxygen minus 1. Now H3PO4, what is the total number of oxygen here? 4. Subtract 1 from it, then 3. So this is our n factor. Now in case of H3PO3, total number of oxygen is 3. Subtract 1, then what we get? 2. So n factor for the H3PO3 is 2. Similarly in case of H3PO2, this is the homework for you and answer is 1. Then why 1? You will see with the help of this trick. Let's start with the base. Now in case of base, firstly we dissociate the base, then n factor is equal to total number of OH ions. Now in case of NaOH, here only one OH ion. So n factor is equals to 1. In case of AlOH thrice, total number of OH is 3. So n factor is equals to 3. In case of magnesium hydroxide, total OH is 2. Then n factor is also 2. Firstly, it's a very easy trick that you have to calculate the OH ions and that is equals to the n factor of that base. Here 2 OH, then n factor is equals to 2. Here only 1. And in case of NH3, similar with the help like SO2, CO2, SO3, we add water. Here also we add water and we get NH3OH. Now 1 OH, then n factor is equals to 1. It's a very easy trick. You have to calculate the H ions in case of the acid and OH negative ion in case of the base. Then these both are equal to the n factor. These both are equal to n factor of that particular acid or base. Then you can calculate normality, Van 't Hoff factor or whatever whenever there is a need of n factor. So apply these easy tricks. Now in case of salt, n factor is equals to total charge on ion. The ion may be cation or anion. but you have to calculate the total charge. Please focus on this line, the total charge. Now in case of NaCl, there is two ions, Na positive and Cl negative. Only consider cation or anion, not both of them, only consider one of them. So in case of Na positive or Cl negative, I will consider Na positive, then total charge is equals to 1. So N factor is equals to 1. Now in case of copper sulfate, now dissociate copper 2 positive and SO4 2 negative. Now consider any of them, we get N factor is equals to 2 because charge is 2 here. On copper positive also 2 and SO4 negative is also 2. Now in case of magnesium carbonate, Mg2 positive and CO3 2 negative, then N factor is equals to 2. But in case of like aluminium sulfate, here is the conflict between these, that aluminium positive 3 and SO4 2 negative. Now what will be the N factor here? Here charge is 3 and here is 2. Now we have to only particular focus on cation or anion. Let's focus on cation. I am considering cation. Now 2 aluminium are here. Now Al positive 3, one more Al positive 3, then total charge is 3 plus 3, 6. So this is the N factor. But if you consider sulfate only, then 3 sulfate are there, SO4 2 negative, SO4 2 negative and SO4 2 negative. Again the total charge is 2 plus 2 plus 2, 6. So N factor is equals to 6. So the main point is that you have to focus on cation or anion, any of them, but you have to consider the total charge on that particular ion. What will be the total charge? Like in case of aluminium oxide, aluminium positive 3 and oxygen negative 2, but here is 2 aluminium, then we consider aluminium positive 3, then total charge is 6, then this 6 is equals to our N factor. So it is a very easy trick, but you have to focus on that particular point, then your answer will be within second. Now in case of ions, in case of ion, the N factor is equal to its charge. N factor is equals to its charge. For example, I am considering Na positive. Na positive. Na positive has one positive charge, then its N factor is equals to 1. Now magnesium positive 2, its N factor is equals to 2. CO3 2 negative, N factor is equals to 2. PO4 3 negative, N factor is equals to 3. Aluminium positive 3, then N factor will be, yes, 3. So in case of ion, it's very simple that you have to calculate its charge, then this is equals to our N factor. So it's very easy trick. Just these points you have to remember, that in case of acid, dissociate the acid, then our N factor is equals to total number of H ions. But in case of phosphorus compounds, just subtract the 1 from the total number of oxygen. In case of base, number of OH ion is equal to N factor. And in case of salt, you have to focus on cation or anion, but total charge will be considered. And in case of ion, it's very simple, that total charge is equal to N factor. So hope you will enjoy this lecture, and please like, share and subscribe my channel. Thank you.